Hi everyone. In this video, we are going to learn these SQL concepts visually. Not only we see visually, we'll also see why these concepts exist in the first place. So let me give a quick overview for all these concepts on how we are going to learn them. So if I show you group by, so this is how we are going to learn. At first we see it visually, step by step. This is the output. So once I explain this visually, then where we see step by step code for these visuals. So we start from here and we go till here. We see step by step visuals and also corresponding code. One more thing, I'll provide you visual metaphor for every concept so that you can remember the concept very easily. The visual metaphor for group by is mixing colors. Why and how we'll see in detail later. Then we go for window functions. See again, here also I'll provide you two real world examples. For example, in Olympic medals, when you have a tie for gold, what will be the next medal? Will it be silver or will it be bronze? Once you learn window functions, you will know the reason. Even when you're learning window functions, rather than showing you these tables, I will give you pictorial representation like this, and this format is followed throughout this concept. And then we go for SQL execution order. This teaches you why we need a subquery. When you're learning SQL execution order, I will provide you a mnemonic to remember this execution order. And then once you complete this, then we finally see the difference between subquery and SCTE. And the visual metaphor for this is a Russian doll. And why a Russian doll, how a Russian doll is compared to subquery, you will see in detail. Everything I will be explaining in detail. Once you complete this video, you will never have any doubt about these concepts. You'll be very confident, and also with the visual metaphors I will provide you, you will never forget them. Please watch this video in sequential order because one concept leads to other. So now let's see how group by works. So if I go to group by, we have a table called sales details and we have 4 columns in it: customer ID, order date, product ID and price. Every row gives us order information. So which customer brought that order, on which date the order was placed, and what was the product item, how much price the customer paid for this item. For product 1, the customer paid $10. For product 2, the customer paid $15, and for product 3, the customer paid $12. Same for every customer, it in every row. What we want to know is in total how much every customer paid. These are all the orders placed by customer A. I want to know total amount customer A spent. Same for B and same for C. So now let's see how to do this. To find out this information, we only need 2 columns: customer ID and price. So let's select this. Only these 2 columns. We don't need this. So let's remove them. Now we can segregate them into 3 parts because we want total amount at customer level. So customer A in one color, customer B in one color, and customer C in one more color. So we can segregate them in 3 segments, 1, 2 and 3, or A, B and C. And then we can perform summation on the price column. To perform summation, see sum of price, it leads to 76. This leads to 76. This leads to 74. And here we get 36. And then finally we can combine again and create this table. This is the final table we got. Now the question is how to write this in SQL. How to translate this output in SQL format. Now let's see that. So if you see again simple sales table. If you want this output, you can simply write select star from sales details. So the simple query we know, the select query. And then we are selecting only 2 columns out of this, which means rather than selecting star, we can say, we can specify the columns, customer ID and price. So again, this is easy. Then we are writing group by. Again, here we can visualize. Again, I'm not claiming this is how internally separates, but this is a visual guide for us to understand how group by works. So we can clearly segregate into 3 segments based on the customer ID. So we are splitting them. You can see splitting them, and then we are applying the aggregation. Here we are performing summation. Aggregation could be anything: summation, count, minimum, maximum, average. We can perform any of these aggregations. Here specifically we are looking at summation. We are applying the aggregation and then again finally we are combining them. So again, this is how group by works. The pattern group by follows is, you can visually see, split, apply and combine. This is a pattern group by follows. Again we are writing here group by customer ID. The same code continues, split. Here we are applying the aggregation, summation of price. Previously we have price. We are writing, we are performing summation on this price column. And then finally we are renaming it as total amount spent. We have summation of price, and here we have total amount spent for this column, this new column. This is well and good. Now we understood group by follows, split, apply and combine methodology, and we can visualize it in this format. So it's like the big table is breaking into small parts and going out and performing some aggregations and then combining again. So split, applying the aggregation and then combining. So that's how group by works. We can visualize it properly. We can visualize it easily. Now the question is, what is the limitation of a group by? So now here, this is the initial table and this is the final output we got. See, now in the process of getting this final output, we are losing some important information. Order date and the product ID columns. The customer is intact. We can use the customer ID in future transformations. So we also got this total amount spent, again literally got from the price column itself. So more or less we have the price information. Not exactly in the same format, but at least we have some information about price. But we completely lost the information about order date and product ID. So that is the limitation of a group by. While performing transformation, group by loses some vital information that we initially had in the process of getting this aggregated result. So now that's how group by works. Again, there is nothing wrong in it. This is the nature of it. So I generally give a visual metaphor for a concept so that we can remember the concept easily. So the visual metaphor for group by is how we mix colors. If you see, once you combine red and yellow, you get orange. But the moment you get the orange color, you cannot say, I don't like this orange, I want red and yellow black. You can't have it. Once you mix it, a new color came and it will exist. Similarly, you should have been thinking about this aggregation before doing it. But once you have done this, you cannot say, please bring back product ID. You cannot do that. At least with group by, you cannot do that. Now, the question is, what if I want both of them? The both aggregated results and initial table. Basically, we are saying I want both red and yellow even after bringing the orange color. For colors, we cannot do that. There is no way we can do this. But at least in SQL, we can do this. This is where window functions come. This is the original table and this is the final output. You see, we have this original table as is without losing any information. And we have the new information that we already got from the aggregated result. We have 76 for customer A, 74 customer B, and 36 for customer C. Now, how do you do this in SQL? See, this is the code for group by. Simply remove this group by customer ID and then add an overclause and partition by customer ID. Instead of doing group by, we are performing partition by and we are wrapping it in overclause. This is where once you run this code, you get this result. Now we have both initial table and then the aggregated result. So basically aggregations within window function compensates for the limitations in group by. When you want aggregated result at row level, this is where you use window functions. And when you want only aggregated results, that's when you use group by. So I hope you understood when we need a group by and when we need a window function. Again, we only looked at aggregation. We have few more window functions. So where do we use them? Why do we need it? So to understand the importance of remaining window functions, let me give you two scenarios. Again, the real world scenarios. See, if you're from India, you know that whenever exam results come, for example, IIT JEE or NEET exam results come, coaching centers give this ad. So one of the ad could be as bizarre as this. So 35 students in top 10 all India rank. No way this sentence should make sense. Literally the meaning of top 10 is there are only 10 people or 10 slots. How can you have 35 students in top 10? Like, how does the math work? It should not, but it does work. We'll see how does it work and why does it work. And also one more question. Let's take, for example, Olympic medals. Simply, let's take swimming. An athlete completed the lap in 40 seconds. The next person took 42 seconds. Another person took 43 seconds. This person will get gold. The next one will get silver. And the last one will get bronze. So the scenario is simple, no confusion. And the complicated scenario comes now. What if both athletes completed the lap in 40 seconds? Let's say there is no difference in the completion time. So both of them will get gold medal. The question is which medal next person should get. This is where conflict comes. The player says I should get silver because my time is second best. The first best is 40. I'm 41 seconds. So second rank, I should be awarded silver medal. So that is player's claim. Now what does committee say? The committee says no, you should get bronze. Why? What is their logic? They say I don't care how much time you take to complete. You take 40 seconds or 40 minutes. We only take care about the people because then it's a competition and competition between athletes. There are two athletes who beat you. That's why you should be awarded bronze. So both of their logic is correct. Player's logic is correct because he's looking at timer and committee's logic is correct because they are looking at players. The question is, what does Olympics do? Will they give a silver or will they give a bronze? We'll also see the solution at the end. Once you understand window functions, you'll see what Olympics gives. Now let's see how window functions are implemented. So again, let's also learn window functions visually. So let's take this. So we have 8 icons. Each represent either it's a man or a woman. So this is a man, woman, so on. We have 8 icons. All these icons are of different sizes. None of them are equal to one another. So now what we can do is, let's sort these icons in ascending order from small to big. So we can do this small to big. This is the smallest and this is the largest. We can also do in descending order. So till now we are clear, ascending order, descending order. Now the question is, I want to know fourth largest icon. Again, we go from 1, 2, 3 and this is the fourth. So this is the icon I'm looking for. What if I want seventh largest icon? Again, we have to go from start 1, 2, 3, 4, 5, 6 and this is 7th. See, 7th. Because we have only 8 icons, we can clearly see this is a 4th and this is a 7th. But what if we have 8,000 icons? Or even worse, we have 80,000 icons. In that scenario, we cannot keep on counting them and check. So suppose we have 80,000 icons. I want to know what is the 4,672nd largest icon. You cannot keep on counting every time. So what is the better way? The better way is to first of all sort them in ascending or descending, whatever you want, but sort them in one order and then add some numbering, add some labeling to it, something like this: 1, 2, 3, 4. So once you add them, add some labeling, you can clearly say what is the fourth. This is the fourth. We have what is the 4,762 again. So we can clearly see then the number on the icon. Same for this. We can simply order in the one order and then label them. So that's the easiest way. But again, even this has some limitations. Here, for every icon, we know either it's a male or a female. This is female, this is female, this is male, and so on. Now, what if I want to know second largest icon within men or fourth largest icon within women? Again, that's a problem, because if you see the second largest icon within men, again, this is one, but again, this is one, but again, this is female, so cancel it, female, cancel. So this is male, again, first icon, this is female, cancel it, second icon. This is what we're looking for. This is second largest icon within male, but the numbering is 5. Again, same for fourth largest woman. If we see here, this is the fourth largest woman, but the numbering says 7. Again, there's a mismatch. So what we can do, we can also take this gender information into account and then sort. We can do men separately and women separately and sort them. So if you see, this is what we can do. We can segregate men and women into different groups and add them. Women in one group and men in one group. Again, now the fourth largest female icon is this, and the numbering also says fourth. And the first largest or second largest, again, this is second largest, again, numbering also same. And so for labeling, we used both the information, the image size and also the image gender. Now let's see how we can translate this information into SQL code. If I see here, if I show you here, yeah, this is the same input here. Okay, if we translate this information into a table, so if you see, we can see, I said we have 8 icons. So this icon 1, 2, 3, so 7 and 8. So 8 icons, 1, 2, 3, 4, 7 and 8. And then again, we have gender information. Icon 1 is male, we have male. This icon is 6, I think, 1, 2, 3, 4, 5, 6. Yeah, 6th icon, we have female. And also we have image size. So this is 2 by 2, which means 2 centimeters in height and 2 centimeters in width. So this is 2 by 2, this is 6 by 6. If you see, this is the highest, we have 6 by 6. And for every icon, we have corresponding gender and their corresponding size. We successfully translated this information into a table. We are calling this table as icons. And then we say the columns are gender and image. Again, we also have something called name column. These are the predominantly most important columns. If you want to display this output, you can simply say select star from icons. Simple select statement. This is where we always start. Again, we are performing ascending order based on the image size, right? It's image size that dictating this order. So we can simply say order by image size ascending. The same select star from icons and order by image size in the ascending order, small to big. So for descending, we can say same code, but image size in descending order. So simple. We successfully translated again this also into SQL code. Now let's see numbering. How do you add this numbering so that we can fetch any icon depending on this numbering? Again, we are labeling these icons with this numbering. So to do that, we have something called row number. So row number, so we are performing order by image size in the ascending order, so small to big, and then we are adding some sequence. In SQL, to add this sequence, we use something called row number. So the syntax is row number, have brackets, it indicates function, over, have something called over clause, over all this information, over order by image size, because we are using image size in the ascending order, small to big, and we are calling this new column as numbering. You can give any name, we are calling it as numbering. You can call it also labeling, we are saying it's numbering. So if you see the output here, we have name, gender, and image size. We are not losing this information because in window function we won't lose already existing information, and the new numbering is based on this image size. The smallest is 1 into 1, so row number is 1, and the largest, this is the highest, is 6 into 6. That's why we got number as 8, because there are 8 icons. So simply we can write row number. Even for descending order, the same thing. Simply we can write image size as descending. So whatever we did, similarly here, order by descending, order by ascending. If you want to add some sequence, this is what we do. Simple. So row number adds some sequence value. So 1, 2, 3, 4, it goes on till the number of values exist in the table. Again, we also did segregation based on gender column. For male icons, there should be one numbering, and for female icons, there should be one more numbering. How to do that in SQL? Now within this row number, we can add something called partition by. We perform partition by and then perform order by image size. We already seen this. We are saying, okay, segregate them or group them or separate them. Basically, we are saying separate them based on this gender. If it's male, it goes to one group. If it's female, it goes to another group. Once you segregate them based on the gender, now perform ordering. Now perform this ordering in sequence manner, and then finally add this sequence, the row number. So at first we perform this partition, which is segregation basically, and then we perform ordering, either it's ascending or descending, and then finally once these two things are done, on this output add a numbering, add some sequence, go from 1 to n equal to number of rows, and we call this new column as numbering. So if you see here, all these are female, all these rows are female. So we have one numbering, 1, 2, 3, and 4. We have 4 icons. Again, for males, again the numbering starts because we are segregating. This group is not affected by this group. Once you segregate, one group is not affected by another group. You can have 5 icons here and have 4 icons here. We can have 4 icons here. Then it will go from 1 to 5, and this will go for 1 to 4. One group or one partition or one segregation will not affect the numbering for other groups. So till now, okay, we complete till here. So if you see, we kind of looked at this scenario. If you see in the Olympics medals, we kind of looked at this scenario. We're ordering and then there is no issue. But the question is, what happens if we tie? Again, how does row number function behave when there is a tie? And is row number function capable of solving this scenario and give us an answer? Whether should we go for players POV or a committee POV? So basically we are saying the scenario is, what if two images are of same size? How does row number behave with this? And is there a limitation for row number because of this scenario? So let's see that. Again, if you see, again here, these two, this one and this one, both of them are of same size. And also this one and this one are of same size. Now we have same size. So if I show you, again, this is icon. Again, if you see the difference clearly here, previously the icon 2 is 4 into 4. Now it's 3 into 3, which matches with icon 4. Then this one matches with this one. 1, 2, 3, 4. Again, 2 and 4 matches icon size. Same for icon 3. Again, 2 into 2. This is 2 into 2. Previously it was 2.5 into 2.5. Now it's 2 into 2, matches with icon 1. So icon 1 and icon 3 of same size, icon 2 and icon 4 are of same size. Now what happens in this scenario for row number once you have performed row number? Let's see again. Again, this also just to show you visually, same size and same size. This ascending order, descending order. Now let's see how row number behaves. In ascending, it goes from 1 to 8. Now here's the issue. Even though both of them are of same size, it says 3 and 4. Ideally 3 and 4 means 3 is less than 4. which means this image size has to be less than this image size, but it's not true. Both of them are the same size. Again, the code is same, the row number, order by image size. See, even though it's taking image size into account while performing the ordering, while labeling, row number is not taking into account that these two are of same size. Same, even if you do in descending order, we have same issue, be it here or be it here. So it has to be same, but row number is not performing the way we want it to perform. So it's not handling the scenario properly. Now if you ask row number, it says, I'm sorry, I cannot deal with this. My job is to add a sequence. I will add it. I don't care whether you have same size or not. I'm not going to care about it. So which means if you see for Olympics, which means in Olympic scenario, here itself it falters. Even though the two athletes completed at the same time, it says one will get gold and one will get scenario. So it's handling this scenario the same way as this. That's a wrong scenario, which means Olympics will never use row number for the scenario because it's giving wrong results here itself. Forget about this, can't handle even this. So this is where we need new logic for numbering. So let's see this. Let's see how we can handle it. So here, so let's take the descending order. This is 3, the image size is same, the image size same. So we are saying the numbering is 3 and the numbering is 3. This is fine. Now what about this? Now again, what numbering should we give here? Should it be 4 or should it be something else? So some will say after 3, 4 will come. Why not add 4? But someone else will come and say, why should we add 4? We should have 5. Why? What is the logic behind 5? See, there are 4 icons that are greater than this icon. So naturally it should get 5. Now the question again we have the same issue as the Olympics. Whether the athlete should get silver or bronze. Same issue here. Whether we should give 4 or 5. One group will say 4, another group will say 5. Again they are fighting each other. This is where SQL says, don't fight. We'll create two functions, use whatever function you want. This is where we have rank and dense rank. Rank says go for 5 because there are 4 icons that are greater than this. And also here, see, again, both of them are same size. That's why they get 5, similar to this. And then again, for this icon, there are 6 icons that are greater than this. That's why they should get 7 and 8. So that's what rank says. So again, instead of row number, we say rank. Rank over order by image size. I think it's descending order here. My bad, my mistake here. It's descending order as numbering. And then we go in this format. We have 3 and 3. And we have for 2 and 2 we have 5 and 5. The next one goes for 7. So basically we are jumping numbers. After 3, rather than going for 4, it says 5. Rather than going for 6, it says 7. So we are jumping some numbers. Dense rank says no, we don't jump numbers. We give value to number system. We go logical 1, 2, 3 and 4 without jumping in number. So the name comes dense rank. Dense means closer together. There are no holes in between here. Because there are no holes in between this numbering system. That's why this is called dense rank. Again here also, my bad, it should be descending. So again 1, 2, after 3 and 3, we get 4 because the logical number after 3 is 4. Again, the logical number after 4 is 5. That's it says 5 and it says 6. 3, 4, we have 5 and 6. And the code is simply dense rank. Now I hope you understood in which scenario we need which function. Now let's go back to our applications. How does this make sense? 35 students in top 10 rank because they're going for dense rank logic. After 1, 1, 1 and 1, rather than going for 5, if you are using a rank, you should be going for 5. Because they are using dense rank, it goes for 2. That's why they say you can claim 35 students in top 10 because you're using dense rank logic. This is what they use. Simple. So now what about this for Olympics? What will Olympics do in this scenario? Will they go for dense rank logic and give the athlete silver, or they go for rank logic and use athlete the bronze? So Olympics goes for rank logic. Why? The reason committee gives is at the end it's a competition. You're competing with athletes. So it doesn't matter you complete the lap in 40 seconds or 400 seconds. Because at the end there are 2 athletes who beat you. That's why you get bronze. Again, now let's go for this scenario. Segregating and then performing the numbering. Again, we are segregating by gender. These both images are same size. We get 2 and 2. Because we are using dense rank, this gets 3. And this gets 3. 2 and 2 this gets 3. Again, the syntax is, how do you perform this partition? We use partition by gender, order by image size, in descending order, thank God. And we have dense rank. Again, at first we perform partition, we then go for order by, and then finally we add dense rank. If it's a rank, it would be 1, 2, and 2. Again, we get 4 here. Partition by, order by, and then finally we go for rank. Same, 1, 2, and 2, we get 4. Okay, now let's look at one scenario. Let's say here, in this scenario, again we have numbering. Again, we are performing a rank. See, 1, 2, we had 3 and 3. Again, we are jumping here. Rather than going for 4, we are going for 5. So basically, we are using a rank function here. That's good. Now the requirement is, I only want image number 7 in the output. So this image, I want this in the output. This is the output I want from this. So how do you do that in SQL? So if you write something like this, select star, again we are ranking, and then finally we are performing where numbering equal to 7. So this should give the output, but it will not. So it will never give the output we want. The moment you write this code and execute it in SQL editor, in any SQL editor, the output will say column numbering does not exist. The question is why? Because, but you can say that's wrong. I'm creating this numbering column. How can SQL say numbering column does not exist? So this is where we get the next concept, which is SQL execution order. SQL execution order teaches you why this code is wrong and what is the actual way to get this output. Let's see this. If you go top, if you go here, so SQL execution order. See, the question is, why do we assume this is right but actually wrong? See, in most languages we write from left to right, and also we read from left to right. Also we see things top to bottom rather than bottom to top. The intuition is, this is how the code runs. So we think, okay, first select runs and these two things are running, then it goes from table and then the numbering. That's why we think we are writing numbering here. Why are we getting it wrong? This is where SQL rules apply. Just like any language, for example, if you take English, we always say, I can clearly say my name is Vamshi, but I will never say name is Vamshi Mai, because English language rules say this sentence structure is wrong and this is right. Similarly, SQL has some order, some rules that it applies. Again, we should follow those orders. So what is the order for execution? At first, it goes for from. Even though we write select, first of all, it checks for the table. It goes for from and it checks the table, whether this table exists in the SQL database or not. So, and the order is, it goes for from and then checks for join, which means it checks for few more tables exist or not, and then goes from to join. Then it goes for where condition, which means it's filtering the tables, and then group by, having, select, and then distinct, and the order by. So if you see, when you write select, when you write where condition, we are writing this numbering column in the select, which means here at this step, but the where condition is executed here itself. When you are executing this condition, this numbering column doesn't even exist because you are writing the numbering column in the select, which is comes at the later step. That's why when you execute this code, you get an error. Again, to remember this order, we have a mnemonic which is called this Frank John's wicked grave horns, several dull owls. Again, even this sentence is also bizarre to remember, but there is a rhythm to this. If I show you, the rhythm is Frank John's wicked grave haunts several dull owls. You see, there is a rhythm at the end. Again, once you remember this mnemonic, you can easily remember the SQL execution order. Again, I came to know about this mnemonic 4 years ago. I never forgot it. Just simply take a piece of paper and write this mnemonic 10 times. Try to write it without seeing, then you can remember it easily. You will never forget this execution order. Okay, now let's see in detail how this code is executed in this SQL execution order. If I show you, we have this order from top to bottom, and let's see at every step what happens. Again, we go for from at first. So from icons, SQL engine first goes for from and checks for the table. If the table exists, it scans the columns in the table, gender and image size. And in this code, it goes for next step, join. We don't have any join. It skips this step and we don't have any where condition. Again, in this, again, we are seeing for in this, not this one. Let's go for this first. There's no where condition. There's no group by. There's no having. We have select. In select, we have all the columns and we are adding one more column as numbering, which is using a rank logic. So if I go here, we have all the columns, which is we are selecting gender, image size. We are creating one more column called numbering here. And then there is no distinct and there is no order by. Once you write this code, only this code, forget about this one. Once you write only this code, it will execute. But once you write this, it will not. Let's see why. So once you execute this, again it checks for icon. It says icon, again gender, image size, and also again we have join. There is no join condition here. Here we see where numbering equal to 7. Within this column names, it's checking for numbering. Because there is no column called numbering in these columns, it says numbering column does not exist in this table. In this icons table, numbering column does not exist. So because we got an error, we don't even go for other steps. It just throws the error for us and the execution is stopped. But now what is the way to solve this? How do I get from this to this? Because that's what we are looking for. Icon number equal to 7. That's what we are looking for. This is where the concept of subquery comes. So what we do is, first of all, we write this query, and on top of this query, we are writing one more query where we are performing this where condition. How do we do? So again, it goes from the same logic till the end, where now we have these three columns, gender, image size, and numbering. So now on top of this, we are writing one more query. So which means again, we are writing, when you are writing one more query, within that query, it goes from top to bottom for the execution order. So once this is run, this goes to top again here. Now this table is not called icons. This is called n, because we are writing this whole query as n. Again, this convention is very important. If you don't give a name to this query, how are you going to refer it? That's why we have to provide a alias. That is the reason a subquery needs an alias, because it has to refer to this query, and that query first runs the original table, and then that original table output will run this query. So when you run a subquery, it goes from inner query to the outer query. It goes from this, it executes this, and it calls this, and we are giving a name to this, and then it executes the outer query, which is this query and this part. And if you see, we have n, we have gender, image size, and numbering. Again, we don't have any join. It skips. Here we have where numbering equal to 7. Because we have this numbering, we can clearly pick this icon from this. That's why you get in the output this one. Because again, we are skipping everything here. We are skipping everything here. We are selecting. Finally, we are skipping distinct and order by, because we are not performing any of those operations. And finally, in the output, you get this. So that is the reason you need a subquery. I hope you understood the SQL execution order and the subquery. And finally, we have concept called CT. Where do we need a CT? So if you see this query, which we wrote previously, so basically we are arranging this subquery, this inner query at the top, and then writing all this query, this query at the bottom itself. So basically we are arranging the code differently. Whether you run this code or this code, you will get the same result. Now the question is, when you already have subquery, what's the point of CT? What does CT offer that subquery does not offer? What compelled people to create a CTE over subquery? If I give a visual metaphor subquery and CTE, the visual metaphor will be Russian dolls. If you see, these are called Russian dolls. These are also called Matryoshka dolls. Again, this is the link. You can go and read about this. But the famous name is Russian dolls. See, Russian dolls are basically dolls with increasing sizes or decreasing sizes, where you can put one doll into the other. You see, you can put this doll into this one into this, and this one into this. And if you arrange them in this format, we have this. So we have an inner doll, one more, one more, one more, and one more. So the difference is arrangement. Both are same. It's visually we are arranging it differently. That is what CT, that is the same thing for subquery and CT. We are just arranging it differently. Now the question is why? Why do we do it? The answer is readability. Okay, this inner query is easy to read because all the code is here itself. But see the outer query, half of the code is here and remaining half of the code is here. But if you see the CTE, whole query is here and then the remaining query is here. We are just naming this query at the top, that's it. But if you see, this is visually more elegant and structurally easier. Again, as I said, first of all the inner query runs and then the outer query runs. Then CT makes perfect sense because, as I said, human intuition is top to bottom. So from top we can see this query runs first and then finally this query runs. So from intuition point of view, CTE is more readable and more maintainable compared to a subquery. See here, because we have only one subquery, it's easy for us to maintain both of them, not a big deal. But again, let me show you one more code. This is the code. Again, both are same. One is subquery and one is CTE. We have three subqueries colored in shades of pink. Shades of pink. This is the query we are going to write for question number 10 in the case study. This is solution for question number 10. If you see, first of all, we need this query, inner query. Once this query is executed, it goes to this. Once this query executed, it goes to this, and finally it goes to the top. So if you see, it goes from inner query to outer query to outer query. Same like this. It goes from here to here to here to here and to here. It's like Christopher Nolan's Inception movie. We have it in the movie. We have dream within a dream within a dream. Here we have query within a query within a query. So both are same. Again, if I arrange this in a CTE format, this inner query will go at the top. Again, we can match them by coloring. This part is darker pink. It goes to here, and these both are same. And then this code goes to the bottom. And finally, this part of code along with this part of code will go here.